Good morning, students. Let us start with our annual term portion. The first chapter is sound. So, first we'll understand what is sound. You must have done this chapter earlier also in standard 7, that what sound is. It is also a form of energy like light and heat. So what is the sensation or the energy will do which type of work? The sound is a form of energy which gives us the sensation of hearing. We can hear sound. Sound is produced by vibration of a body. It's not like that all the vibrations of any object we can hear. So for that, different animals, different human beings, different living organisms have different audibility range. So we can hear within the audibility range of 20 Hz to 20,000 Hz, or we can say 20 Hz to 20 kilohertz. That is the audibility range of a human being. Sound travels in the form of waves. That we will understand in detail, that how sound travels in the form of a wave, forming a series of compression and rarefaction. What is compression and what is rarefaction? So as you can see here, that compression is the region where the particles that vibrate, that are very close to each other, the density of the particle is very high, and where the particles are spread around with very less density, means the particles are far apart from each other, that region is known as rarefaction. So as sound travels in the form of wave, and that is in the form of longitudinal wave, that also you had done in standard 7, that sound travels in the form of longitudinal wave that forms compression and rarefaction. The simplest example to understand this compression and rarefaction is of a spring. If you are going to take a spring and if you are going to press it, compress it, that is the region of compression. Again you release the spring, you will get the region of rarefaction. Then we will discuss in detail about loudness or intensity, pitch and quality or timbre. These are the characteristics of sound waves. Means what? To describe the sound waves, how we can differentiate between different types of sound wave, how we can distinguish between the different sound waves. So it will give the characteristics of the sound waves. Before that, first let us move on to the terms that we are going to use to define the different characteristics of sound waves. Let us discuss those terms related to sound waves. Here we have taken a sound in the form of a wave in terms of distance and pressure. The maximum height or the maximum displacement on the either side of the mean position is known as the amplitude. This is the amplitude of the sound wave. This is the sound wave. This is the amplitude of the sound wave. This is also the amplitude of the sound wave. Next thing is the wavelength. The complete length of one complete wave is the wavelength. Means we can say the distance between one compression and rarefaction, or this is one crest and trough. So one crest, one trough. If it starts from here then it will end at here. If it will start from here, the length of one wave, then it will end at here. So that is the meaning of one complete wavelength. So here at the maximum point, the point of the maximum compression and maximum rarefaction, there maximum rarefaction, maximum compression, maximum rarefaction, here is the crest, here is the trough. So we can define sound waves in the form of compression and rarefaction, or crest and trough. In the form of compression and rarefaction, longitudinal wave, crest and trough in the form of transverse wave. Now, oscillation or vibration. The complete to and fro motion of an object, like if you are going to describe it like this, if a pendulum is there and if you are going to oscillate it, so one complete to and fro motion. So if it will start from here, it will go this one extreme, another extreme, then again return to the mean position. That is one complete oscillation or one complete vibration. Now, time needed to complete this one oscillation or vibration is known as time period, that is denoted by capital T. So, what are the terms we had discussed now? Amplitude, the maximum displacement, crest and trough, compression and rarefaction, one complete wavelength, oscillation, time period, time required to complete one oscillation. Now, in 1 second time, what is the number of oscillation being made? In 1 second time, maybe 1 or 2 or 3 oscillation being made, or vibration. Like if this is a steel rod and it will vibrate, then in 1 second time, how many times it will complete the number of vibration, that will give the term frequency, that is denoted by small f. So, small f is inversely proportional to the time period. So, these are the terms related to sound waves. To describe a sound wave: amplitude, wavelength, oscillation, time period, frequency, crest and trough, compression and rarefaction.